So good evening everyone. Hello, am I audible?
Yes, Sunny.
Okay. So good evening. My name is Amit Kumar Sharma and today I am taking your first live session of the course Non-Conventional Energy Resources. Uh, the course instructor is Professor Pratap Haridosar from IIT Madras and I am his TA Amit Kumar Sharma. So first I briefly explain that in this live session what I will cover. Okay. And first of all let me tell you something that this session is being recorded. Okay, and I will share the recordings with you on the Google, and I will also share the PPTs. So this will be beneficial for you, and it will be also helpful uh, those who are not able to join today. Okay, so basically in this live session, we will discuss some important concept during. Okay, okay, let's wait for 5 minutes, then we will start because people are joining and joining again and again. So let's wait for 5 minutes and then we will start. So okay, no one is coming now, so I think we should start now. So basically, we will cover some important concept that were taught you during the first week of the classes. Okay, so we will discuss some important concept and we will discuss some sample problems in this class. So based on those problems, you will be able to solve the current week assignments. Like in this class, I will discuss about the week one. So in week one there were three lectures. So I will briefly discuss about some important concept of those lectures, and we will do some sample problems for the week one based on the concept you learned during the classes, and based on those concept you can easily solve your current week assignment questions. So that will be very helpful. So is my slide is visible to you? Is my PPT visible?
No, sir.
Yeah, please 1 minute. Is it visible now?
Yes, sir.
Yeah, okay, thank you.
Yes, sir.
Okay, thank you. So this is first live session. I will cover about the week one. Okay, and my name is Amit Kumar Sharma. Those who joined recently for those. So this is a quick revision of the week one. In week one, we have covered various type of units. We know that unit is very important, like in our daily life or like in 1 minute. This is difficult. Anyone know that is any option that I can bypass this admit option? Anyone know how to bypass this admit option? Actually, I'm new to Google Meet. Okay. Okay, so these are the units we have covered in the first lecture. So units are very important in engineering or in every aspect of the life. Whenever we want to explain something, we need to use some units. Like when we are purchasing something, some vegetables or some household groceries, we need units like kg, kilogram. It's difficult that everyone is coming and it's disturbing the class actually. So I think next time we will plan the meeting on Teams. So in Teams there is option to bypass the lobby, so and anyone can join directly, and I don't have to admit individuals. Anyone know? Is there any option in the this Google Meet? Anyone? Okay. So my screen is visible now. Hello.
Yes, sir.
Yeah. Okay. So the first unit is femto. So it's a unit is it's a 10 raised to power minus 15, like femtosecond laser. So this is unit to explain the femtosecond laser, and femto is 10 raised to power minus 15. In medical, we use these terms. So femtosecond laser is used in medicals, like medical surgeries. Now the second one is pico. It's 10 raised to power minus 12. So pico ampere current sources. So these are using in instrumentation part. Then nano, 10 raised to power minus 9. Nanomaterials, we use in this in nanomaterials. Okay, then is the then it is micro. So it's 10 to power minus 6. Okay, like microstructures, like milli 10 to power minus 3, millimeter, kilogram 10 to power 3, and mega 10 to power 6. Megapixel, it's used in the photography, and we also use like megapascal if you are mechanical engineer, like when we represent the stress, and megapascal is there. So mega 10 to power 6, giga 10 to power 9, so gigabyte ram, 10 tera is 10 to power 12, like hard disk. Like we say that 1 TB hard disk, 2 TB hard disk, so we represent the unit in tera, so it's terabyte. Then there's a peta. So peta for supercomputers. For supercomputers, we use peta, 10 to the power 15. Then exa, 10 to the power 18. So the world's annual energy uses, it's around 500 exa. Okay, so it's representing 10 to the power 18. Then zeta, zeta like 7 zettabytes zeta in 2020. So it's 10 to the power 21. Okay, so for zeta 10 to the power 21. Then iota is 10 to the power 24, like 100 mil light years. It's a distance, showing distance around 10 to the power 24. So these are the units we use in our engineering coursework, we use in daily life, and we use in other aspects. Now move to the summary of power uses and energy storage. Uh, so these are some devices, and these are the power uses and energy stored. So like pacemaker, we know the pacemaker is very important part, like in today's life. There are like due to our lifestyle, we are facing heart diseases. So pacemaker is very good. Those person are facing difficulty in pumping the blood. Okay, so pacemaker is a device that regulate the heartbeat. So it can be installed on our body, and it will control your heartbeat. So it's very important, and it's very life saving device. So it's typically used 6 into 10 to the power minus 5 watt of power, and energy storage 2.5 watt hour. Okay, and this is KCOFX 100 watt. So KCOFX is a calculator. So it's power is at 1 into 10 to the power minus 4, and energy stored is 3 watt hour. Then digital camera, so its power is around 3 watt, and energy stored in the battery is 6 watt hours. Household bulbs like 10 to the power 2 means 100 watt, like in household bulb in the range of 100 watt. Okay, 40 watt, 100 watt range. Hubble telescope, so Hubble telescope in the range of 2.4 kilowatt, 2.4 10 to the power 3. Then again household appliances 10 to the power 3. Then car ignition 5 into 10 to the power 3, so 5 kilowatt basically. It's BHEL bus 2 into 10 to the power 4, and so Honda Insight. These are the like summary in 10 to the power minus 10 to the power 6. So please try to join on the time next time. Okay, it will be very good for everyone, because I think in Google Meet there is a disturbing option that every time I have to admit, so actually disturbing the class. So please try to join on the time 6 o'clock. So every Monday we will meet at 6 p.m. Okay.
Yes, sir.
Okay, I will try to change the link to Teams. Okay, so we will update you. We will update you on the course web page. So the new link will be shared with you. So with that link, there will be no such issues. So I can bypass the lobby in the Teams. So next time I will take care of that.
Yes, sir.
Yeah. Okay. So based on these two, like the units and the basic summary of the power used and energy storage, what are the basic questions we can frame from those course actually? So match the following items and their closest size, scale, or order of magnitude. Okay. So in the left part, device are mentioned, and the right part order. So we have covered the orders of the units. Okay. So portable hard disk. So we know the hard disk are in. So hard disk are in terabytes. So A will match with the tera. Then overall data created and stored by the humanity by 2010 is in Zeta. Okay, world annual energy usage is in the range of exa, like 500 exa. It's very important data. It will also useful in your some numerical also. And the supercomputers, it's in peta. And NGC 5746 is a galaxy. Okay, so the distance of galaxy is 100 light years. It's measured is in iota.
Excuse me, sir.
Yeah, please.
Sir, will you share this PPT to us?
Yeah, I will share the PPTs. I will also recording this session, so I will share the recording with you also, so don't worry. All the data, all the material will be shared with you.
Okay, sir. Thank you.
Yeah, after this class I will upload this data, and the link will be shared
Okay.
with you.
Yes, sir.
Yeah, so the correct answer will be A3, B4, C2, D1, and E5. Okay. So similarly, the second question is the device and their power uses. So in the second slide, we have seen some power uses for some devices and energy stored. Okay, so based on this, this question can be framed like car batteries. So car batteries store power in the range of there are options like kilowatt, megawatt, okay, microwatt. So microwatt cannot be for car batteries. So we know that this zero point 0.6 microwatt for the pacemaker. Okay, and the Hubble telescope is around 2.4 kilowatt. Okay, Hubble telescope is using some batteries of 2.4 kilowatt and also solar cells. So Hubble telescope is using solar panels and also batteries. So when the telescope in the range of the sun, like sunlight is falling falling on the solar panels, then the power the Hubble telescope use from the directly solar panels. And in the case there is a darker area, if the telescope in the darker area, then the batteries can be used for the power the telescope. So that is in the range of 2.4 kilowatt. Then the submarines in the range of like megawatt, because we know submarines we need huge power to power submarines, because submarines are having various type of equipments, and it's also how and there is also various there is manpower also, and we require so much of power to power a submarine. So it is in the range of 1 megawatt. Okay, and car battery in the range of 5 kilowatt. So the correct answer is A2B4. A2, B4, C5, D3 and E1. Now we have also covered about the atmosphere and air also. So these are the major constituent of the dry air by volume. Okay. So air is very important part. Okay, because air is having oxygen, and oxygen is the main vital for the living beings. So basically air contain nitrogen 78.084%, oxygen approx 21% or 20.946 exact, argon, carbon dioxide, neon, helium and methane. So in this composition, the water vapor is not counted, okay, because the water vapor can be changed. Like if you are in like desert area, then there will be very less water vapor. Maybe you can say in the range of 0.001%. If you are in the coastal area, then water vapor percentage may vary. So we are not taking water vapor, we are taking the dry air. So the composition of dry air is nitrogen, oxygen, argon, carbon dioxide, neon, helium and methane. So we know that the nitrogen, argon, these are inert gases. So they do not react. Okay, the main is oxygen. So we require oxygen. Okay, to live, it's very important. And the other one is carbon dioxide, CO2. So CO2 is percentage 0.04%. So we know that CO2 is a greenhouse gas. Okay, CO2 is greenhouse gas. Today we know that climate change and global warming is a very big threat to the humankind, and this is all because of CO2. CO2 and some other factors are also there, but CO2 is a major contributing part in it, because we know that from the after Second World War, when the industry era began, industry revolution began, then we are exploiting the fossil fuels. We are using energy in a very high demand. Like today, you can see that in a simple house, like we are having fridge, TV, okay, and we are also having vehicles. In every room we are having multiple light, decoration light, everything. So these every machine, everything require energy, okay, and energy is generating from the fossil fuels. We know that most of the energy is generated from the fossil fuels. So when we burn the fossil fuel, there are emissions. So in emission, the major part is carbon dioxide. So this carbon dioxide percentage is increasing. Now my screen is visible now?
Yes, sir, it's visible.
Yeah, okay, thank you. So carbon dioxide is very, we need to focus on this because the carbon dioxide normally in the balance, like balance atmosphere, the carbon dioxide is only 0.04%, but due to the exploitation of the fossil fuel, due to the heavy demand of energy, we are increasing the carbon dioxide percentage in the balanced, in the balanced air, okay. So this will create severe problems like we are facing today. Global warming we are facing, climate change we are facing, okay. Due to this, uh, you can say the severe condition are due to the pollution. So we will cover about this, about CO2. We will look into it. Now there are also multiple layers of atmosphere. The first is troposphere, then stratosphere, mesosphere, and thermosphere and exosphere. These are the kilometer range, like 0 to 12 kilometer. We are having troposphere, 12 to 50 kilometer, stratosphere, 50 to 80 kilometer, mesosphere, and 80 to 700 kilometer thermosphere, and then 700 to 10,000 kilometer exosphere. So the most of the our atmosphere is in the troposphere, 0 to 12 kilometer. Like most of the atmosphere mass, like around 80% is in troposphere, okay. And the aeroplanes are also fly in the troposphere in 10-kilometer range, okay. And other are like this stratosphere contain ozone layer, okay. Mesosphere, thermosphere, okay. Now these are the composition of crude oil by weight. So crude oil is also very important, because most of the energy we are getting from the crude oil only, okay. Because you can see the petrol, diesel, all are derived from the crude oil, because from oil wells we only get the crude oil, and we in refineries we refine the crude oil to multiple products, and those products are various chemicals, okay. And the main products are petrol, diesel, kerosene, some gases also. So these are all the parts of crude oil, and crude oil contain, these are the elements. So it contain basically the carbon 83 to 85%, hydrogen 10 to 14%, nitrogen 0.1 to 2%, oxygen 0.05 to 1.5%, sulfur 0.05 to 6%, and metals less than 0.1%. So these are basic composition of the crude oil by the weight. So the carbon is the in maximum percentage. So carbon is there, and we know that where is the, when the carbon comes in the picture, then the CO2 will also come in picture, okay. Pollution will also come in the picture. So that's why the fossil fuels are having huge part in the pollution. Today we know that we are getting the energies, electricity. So it look like just we are getting electricity from the grid, but the grid also getting from the electricity some thermal plant, and in that thermal plant we are burning the coal. We are generating the electricity from coal only. So basically we are generating the electricity from fossil fuels. But today we are making various efforts to reduce the dependency on fossil fuels, and we have achieved some very good numbers. Like we are today we are very forward in solar use. Okay, so solar energy is very good in India, and we are also moving towards hydrogen. Like recently, Government of India launched National Hydrogen Mission, in which they have sanctioned around 19,000 crore rupees for hydrogen research and for various companies. So hydrogen is a clean fuel. It's very simple, H2 only. Okay. Hydrogen is like having highest. It's very disturbing actually. Yeah, I'm sorry everyone. It's like disturbing now. So I will in next class I will choose the team platform. In that platform, there will be no such issues. Like in Google Meet, there is no option to bypass the lobby. So that's why we are getting disturbance again and again. Sorry for this. Next time, I will choose teams. So this is a photo taken from NASA. So this is the photo taken at night time. So this photo is compilation of various like thousands of images. Okay. So so NASA takes images from Hubble telescope or some other satellites. Okay. So using these images, they compile a one single image. So this image is showing the like you can see the some darker area and some light areas where we can see you some lights. So it basically showing the energy use pattern. Okay. So you can see the India here. So here you can see the India, okay, and other countries also. So basically, the darker area it may be forest, okay, and some other areas, and the lighter and the area where you can see some bright spots. So on those area, the lights are there. So the world energy uses per year is around 500 exajoules. Okay, so we have covered the unit of exa earlier. So now based on these revision, like what are the major constituents of dry air and layers of atmosphere, these questions can be framed. Like arrange the following in increasing order of their volume percentage in dry air. So the dry air given in the question, and we have given some components of the gases, and we have to arrange the component as per the increasing order of their volume percentage in dry air. So the maximum is nitrogen. After that, oxygen. So nitrogen is about 78%, oxygen is about 20 20.946%. Then argon, then CO2, then neon, then helium, then methane. So the correct answer will be N2, O2, argon, CO2, neon, helium, and CH4. So these type of question can be framed Now, next question is meteors burning off generally occurs in space and the jet.
Sir,
Yeah, please.
sir, will you show me the previous questions 1 minute?
Yeah,
Yes, sir. Thank you.
okay.
Uh, sir, the option is not visible here.
Yeah, 1 minute, 1 minute. Yeah, I will share the slides, so you don't
Okay,
have
sir.
to take picture or note down the question. Just understand the concepts. I will share the slides, and I'm also recording the this meeting, so I will share the recording also.
Okay, sir. Thank you.
Yeah. So meteors burning off generally occurs in space, and the jet liners fly in space. So basically, this question is asking about the like in which layers of atmosphere this phenomena is occurring. So the meteors burning off generally occurs in the mesosphere, and the jet liners fly in the troposphere. So troposphere, like jet liners, fly in the range of up to 10 kilometer, 0 to 10 kilometer. Like when you fly, then sometimes the pilot announced that we are flying at this height, at this speed, and the temperature outside is like this. So next time when you go in a flight, so try to observe this data. Okay. So basically, the flying range is between 0 to 10 kilometer. Sometime more than 10 kilometers also there for the long distance flight. So they achieved their highest cruising elevation, but normally, but generally, it's between 0 to 10 kilometer only. So what is the meteors? So we can say that when the meteoroids enter the Earth atmosphere. So basically, the meteoroids enter the Earth atmosphere or that of another planet like Mars at high speed and burn up. So the fireballs or shooting star are called the meteors. Okay. When a meteor survives a trip through the atmosphere and hits the ground, it's called meteorite. So there's a basic difference. Meteoroids. So the important points are you can say the meteoroids, meteors, and meteorite. So meteors, it means the burning up is occurred. Okay. So the meteorites cannot survive the Earth atmosphere, and it's burned up at high speed, and like the fireballs or shooting star like phenomena we can see, so it's a meteors, but the meteor when survive a trip through the atmosphere and hits the ground, it's called meteorite.
Sir,
Yeah,
sir, meteors is called shooting stars or fireballs, right?
yeah, meteors, yeah, meteors.
Okay, sir. Thank you.
Yeah, so the answer is mesosphere and troposphere. Now approximately 80% of Earth's atmosphere mass is in the, so I have already revised in this slide, earlier slide. Yeah. So troposphere have approx 80% mass of the total atmosphere. And you can say you like 0 to 12 kilometer, you are thinking very big size. Okay, 0 to 12 kilometer. For a road, when we are moving on the road or we walk, then 12 kilometers is a very big distance. But the radius is very less. You can imagine like this is our Earth. So radius of Earth is very high. It's around 6,325. Uh, uh, you need to check the in the professor lectures what is the exact data. So roughly you can say that 6,000. Suppose 6,000. Okay, kilometer is the radius of the, okay, is the is the radius of the Earth. Okay, So the it's 012 kilometers is very less as compared to 6000. So you can say it's just a pent, like coat of a pent on a ball. Okay, suppose you are having some equipment, some spherical globe at your home, and you put some you put a layer of paint on that globe. So our atmosphere is like that only. The thickness of the paint on the globe will be very small. So our atmosphere, with comparison to the Earth, is only a thin thickness of a paint layer, like that only. Okay. So the troposphere is the correct answer. So approximately 80% of the Earth's atmosphere mass is in the troposphere. Now time required to double the CO2 in the atmosphere at present rate of usage is, we have to find out the number of years, like we have discussed, like 0.04% is the CO2 by volume in our balanced atmosphere. Okay, and it is calculated based on the assumption of. So when we are finding out something, we need to assume something. Okay, so the assumption, what are the assumptions? So we are having two options. The first is all atmosphere is within the troposphere, all air is released through the carbon combustion. So yeah, we have to assume this. So basically troposphere is containing 80%, troposphere is containing 80% of the mass. Okay, so so we will assume that this assumption is correct. And second one is that all energy released is through carbon combustion, because basically we have already covered that we are only like looking about the fossil fuels. Okay, so basically we are talking about carbon. So we will consider that the all energy released is through carbon only. So these two assumptions will be correct for this statement. Okay, so you can say the option 1 and 2 will be correct. And now we have to find out the time required double the CO2 in the atmosphere at present rate of uses in years. So the percentage is 0.04%. Okay, so for this we need to look into some data like combustion of carbon. So what is the enthalpy of formation of CO2? Okay, so when carbon burns, so there is some enthalpy of formation is the for CO2. Okay, it's minus 394 kilojoule per mole. So what is the meaning of minus here? Anyone can tell what is the meaning of minus when we are talking about the energy of formation? So there is sometime plus sign, sometime minus sign. So anyone can tell me that what is the meaning of minus sign in enthalpy of formation?
Exothermic, sir.
Yeah. So basically, minus sign indicate that when the reaction is happening, this amount of energy is releasing. Okay, exothermic. And suppose there is plus sign, what is that meaning? Anyone else from the please don't answer last person. Anyone else? Any other? Suppose the plus 394, then what is the meaning of that? So basically there are two reactions, exothermic and endothermic.
Exothermic. Plus
Yeah,
indicates endothermic, sir.
yeah, right. So basically when we are talking about the enthalpy of formation, okay, for any chemical reaction there are two type of reaction. First is exothermic and endothermic. In exothermic reaction, when the energy releases, okay, when suppose some component is reacting, suppose carbon and oxygen is reacting and forming CO2, so this reaction, okay, is releasing the energy, so is exothermic. And suppose this reaction cannot happen at the atmospheric pressure or like the like standard temperature, so we need to give some heat to happen this reaction. Okay, after at a certain temperature only this reaction can happen. It means that after gaining certain amount of energy only these components can react. So this will be endothermic reaction. Okay, so for combustion of carbon, the enthalpy of formation for CO2 is minus 394 kilojoule per mole. Yeah, so this data is very, this 394 is very important actually. It will be used in some numericals, and it's also important for your assignments also. Okay, so also there is STP. So standard temperature and pressure. So we are considering 0 degree and 1 atmosphere. Okay, 0 degree and 1 atmosphere. There is also NTP. So anyone can know, and anyone can explain what is the NTP and STP? Anyone? Okay. So STP is standard temperature and pressure. So we are considering 0 degree as a standard temperature and 1 atmosphere pressure as a standard pressure. Okay. So in NTP, normal temperature and pressure. The temperature in NTP is around 25 degree centigrade. Okay, is there anything issue in the this link? Because I think I can see some people are just left and again joining again and again. Is there any issue with the link? Yeah, are you getting any issue in the link?
No, sir, for me it's not any problem.
Okay, if there is any issue in the link, please tell me. Okay.
Okay, sir, sure, sir.
Yeah, let me share one backup link also. So in the chat box, I am putting a backup link because I think my Google Meet is free version. So after 1 hour, this free meeting can be stopped. Okay. So please rejoin on this after 1 hour when the meeting automatically disconnected. Please join on this link. Please copy this link in your systems. Okay. In chat box, I have pasted the link. You can copy it. Yeah, please copy the link in the chat box. Okay, in the case of any failure or like after 1 hour, this meeting may be automatically disconnected. So next, instantly, please join on this other link. Let me also write down a message. Okay, so PPT and meeting recording will be shared. Those who joined late, you can see the chat box for the messages. Okay. So the STP is 0 degree and 1 atmospheric. So basically, we are taking 0 degree as a standard. It doesn't mean that the temperature is 0 degree everywhere, but we have to make a standard. So we are putting 0 degree as a standard, 1 atmospheric pressure as a standard pressure, and NTP around 25 degree and 1 atmosphere. So these data is very important actually when you are handling like some chemical products like for example petrol, diesel. Okay, so the density is also vary as per the temperature. Okay, so suppose you are filling so the petrol density is very the density of petrol, or you can say the gasoline, okay, is highly variable with the temperature. So suppose there is a depot of HPCL, you can say the HPCL depot is there. So HPCL depot is receiving the petrol from some refinery or some other depot also. So sometimes you have seen some big tankers in petrol pumps. So those tankers are just filling the ground tank of that particular petrol pump. Okay, so just they are emptying their tanker to the particular petrol pump. Okay, so in this transaction the density play a very important role. Okay, because when the density changes, the volume also changes. Okay, so petrol is a very costly thing, so the rate depends. Suppose the tanker filled the tanker was filled in the morning. At morning, suppose temperature was 15 degree. Okay, and suppose density was around something x. Okay, so when the tanker reached the petrol pump, okay, because petrol pump was having some demand of suppose 20,000 liter, so the tanker filled with petrol at morning time at temperature 15 degree, this the particular petrol pump, and start the emptying the petrol pump to the emptying the tanker to the petrol pump. Okay, but now the atmosphere temperature is around 35 degree. Okay, so there is 20 degree difference. So 20 degree difference will change the density of petrol, and it will change the volume. Okay, so the volume will be changed, and the mass flow meter, okay, from which the amount of petrol is measured. Okay, like when you give 500 rupees, like fill the petrol of 2 liter or 3 liter, so they are having some mass flow meter. So mass flow meter calculate the mass flow based on the densities also. So density is playing very important role in that. Okay, so in this transaction there is a huge margin of error. So that's why we are having some standard data. We have to take some standards. So the petrol pump, the dealer, and the supplier, everyone will measure the density as per the NTP, normal temperature and pressure. Okay, they are using NTP, not STP. In some time we also use STP. So they are taking 25 degree as a standard temperature. So they will convert this 35 degree temperature to 25 degree. So they are having some conversion tables. So as per those, they will convert the density and will calculate the flow accordingly. So this is very important. So temperature plays a very important role. So the STP is 0 degree and 1 atmosphere, and NTP is 25 degree. Okay, sometime when we are also talking about the flow rates of gases, so you have seen like suppose we are talking about the biogas flow rate, like biogas flow rate 5 meter cube. So it's 5 meter cube can be it's like confusing. So we should write 5 n meter cube. So n means normal meter cube. So is this n stand this n indicating that the flow rate is at normal temperature and pressure. If I am writing 5 s meter cube, it means that I am talking about the standard temperature and pressure. So it's very important, this s and n for a flow rate. When we are talking about the gas flow rates, then this temperature is very important. because with the temperature density varies, the amount varies. Okay, so whenever you see the flow rates, then there should be always N or S mentioned. Okay, so these are specifying the normal condition or standard condition. So 1 mole of CO2 correspond 22.4 liter at STP. Okay, means 22.4 into 10 to the power minus 3 meter cube, because 1 liter is equals to 10 to the power minus 3 meter cube. Now, therefore this 5 into 10 to the power 20 joule. So this is the annual energy consumption of the world. Okay, 500 exa. In initial slides, we have covered this, like this exa 10 to the power 18. Okay, unit is exa 10 to the power 18 world annual energy uses, and this is the image. Okay, so in this image, we can see the 500 exajoule is annual consumption. Okay, and these are the areas where the consumption is more. You can see this area is having more consumption as compared to these areas. Okay, so now we have assumed in this question that all energy is released through the carbon combustion. Okay, all atmosphere is within the troposphere. So when we have assumed already that the all energy released through the carbon combustion, and we are knowing the enthalpy of formation for carbon, so for CO2 is minus 394 kilojoule per mole. It means that the energy is coming from the carbon. When the energy coming from the carbon, so the CO2 will be there. So we will divide this complete energy, annual energy, 5 into 10 to the power 20 into 22.4 10 to the power minus 3, because this is the volume. Okay, 1 mole of CO2. 1 mole of CO2 correspond to this much of volume, and this is the kg per mole enthalpy formation for CO2. 394 we are converting units to like 3.9 10 to the power 5. Okay, so when you calculate this data, it will give you the amount of CO2 released. 2 into 2.843 into 10 to the power 13 meter cube of CO2 will released for this much of energy. So if we require 500 exajoule of energy, so and this the complete energy is only released from like carbon or fossil fuel or coal. Okay, so it will release this much amount of CO2. Okay, now we have asked in the question that the time required double the CO2 in the atmosphere. Okay, at the present rate. So we found out that this is the present rate. Okay, so 2.843 into 10 to the 3 meter cube of CO2 per year for this energy consumption. Now, therefore, the time required to double the CO2 in the atmosphere at the present rate of use will be so just divide this 2.45 into 15 to this. So it will be 86 years. Okay. Is meeting active? Are you able to hear me?
Yes, sir.
Okay, okay. Yeah, just 1 minute. Just I am taking glass of water. Okay, 1 minute. Okay. Now the next question is find out the genuineness of the below given statement. So we are having two statements. Like enthalpy change for the formation of carbon dioxide is an endothermic process, and second one is enthalpy change for the formation of carbon dioxide is 394 kilojoule per mole. So we have both covered that the enthalpy change of formation is carbon dioxide 394 kilojoule per mole, but it's positive or negative? Yeah, tell me. It was positive or negative?
Negative.
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 So this statement should be correct or not? So this will be false. And the first one is enthalpy change for the formation of carbon dioxide endothermic. So it was endothermic or exothermic?
Exit.
Yeah, it was.
Exothermic.
Yeah, it was exothermic, right? Very good. So the both statements are false.
False.
Yeah. Now this is a timeline that is showing some very important data regarding the what was there and like what was the change in for energy. Okay, so like 4.5 billion years, you can say age of the earth. 3.8 billion years ago life appears on the earth in form of single cells. 500 billion years ago plant and animals begins to appear. 200 million years ago mammals were there. Okay, 60 million years ago dinosaurs go to extinct. Okay, so 2 lakh years ago homo sapiens. 347 common era, like China earliest known oil wells. So these data are important. Okay, from the point of like how the consumption is changing. Okay, so oil wells mean from the wells where you can get the crude oil. Okay, like in Arab countries, the maximum, like in Venezuela, in Arab countries. Okay, so they are having oil wells. So first was discovered in 347, okay, common era, and in 1859 first modern oil well, okay, Drake oil well, United States. It was found in United States, Drake oil well. This was modern oil well. And 2017 global oil production nearly 100 million barrel a day. So barrel is a unit. One barrel means 159 liter. Okay, one barrel is equal to 159 liter. So barrel is a very important unit. Like when the price of oil changes, so it depend on the what is the price of oil in the global market. Okay, because today in India, like Indian oil, HPCL, all are changing their price daily. So they are changing the price as per the global markets. Global markets mean the global markets price are depending on the barrels. Okay, so this is also having a great point of politics. Like we have seen that the because the oil is the, like fossil fuel and oil are the main source of energy. Okay, and energy is very important. So you can see the some major wars were dependent on the energy only, oils, for the oil only. So who will take care the oil wells? You can refer the history and you will know the major war was depending on the oil wells, for oil wells only. Okay, in Arab countries. You can say also in Afghanistan also, and some other areas also. So this is a very hot topic. Okay, and you can see the production. 2017 the global oil production nearly 100 million barrels a day. Okay, 100 million barrels a day. It's very huge. So you can see the energy demand from this. And again, the population is increasing, so energy demand is also increasing. That's why we are shifting towards the green energy. So not only India, and the UN is also focusing on the green energy, okay, sustainable energy. So recently UN launched like sustainable development goals. So SDG 7, it's very important. Like SDG 7, like there are 17 total goals. Okay, so in which the SDG 7 is basically focusing on the clean and affordable energy. Clean and affordable energy. Okay. So you can find out more on Google. Actually, SDG is very important topic to cover. Okay. So next time we can discuss in this also about SDGs in next class. So basically, clean energy is very important because the fossil fuels are also limited. Because the most of the energy today we are using, it's coming from the coal thermal plants. Okay, so coal is limited. Actually, we are like coal is limited actually because you know how the fossils are formed. We will cover in the next slide. So the fossil resources are limited. We cannot depend on the limited resources because our population is increasing very fast. Our demand, you can see our life today, we are having huge demand of energy, and new gadgets are coming, new things are coming, so the demand is continuously increasing. The demand is increasing in exponentially manner. Okay, so we need to find some renewable resources. That's why we are shifting towards solar, we are shifting towards the wind, we are shifting towards hydrogen energy. Okay, so these areas very important. Now you can see the crude oil 50 to 100 basic cost. Okay, so you can see the this cost 50 to 100 US dollar per barrel. Okay, for 159 liter of oil. Okay, so are you think do you think that this cost cover the complete cost of the fossil fuel, like only this much amount of is only for cost? Yes or no? Like what are the conditions to form the fossil fuels, like heat, pressure, absence of oxygen, and millions of years? When these all conditions met, then only oil, okay, fossils, coal formed based on these conditions. Like this is the sea level, see, this is the mud at the turn into rock. So at the bottom of the sea, so mud turned into rock, then dead plants and animals in the seabed. Okay, so these dead plants and animals are there for millions of years. There is no oxygen. These the rock above these are putting the pressure on these dead plants and animals. Okay, due to confined environment, there is heat also. So heat, pressure, absence of oxygen, and millions of year time. These all conditions are converting the dead plants and animals to the fossils. Okay, fossil fuels. You can say crude oil, coal, natural gas, and other fossils. Okay, so when we are like extracting the oil from oil wells, okay, we are only considering the like the manpower cost. We are considering the equipment cost. We are considering the transportation cost. We are considering like some other costs that are related to the extraction part. We are considering refining cost. Like we are considering multiple costs, but the main point is that no company or no one is considering these data. Okay, heat, pressure, absence of oxygen, millions of years. So when we are when any company is considering the cost, they are not considering these costs. They are considering only the outer costs. Okay, so basically they are treating like this was there only for us only. Like fossil fuel, just like fossil fuel is just only there. We have to just tap it off, but they are not considering these costs. Okay, but it's very huge actually, millions of years. Okay, so once you can think that suppose we are using in very expert manner all the fossil fuels, and after a certain point of time the fossil will end, then what will we do? Okay, because we have to wait another millions of years to generate more fossils. Okay, and it's very difficult. Like today the population is increasing rate very high, and energy demand is also very high. Okay, so if we are going at this rate, so maybe in 100 or 200 years fossil will be at the verge of extension. Okay, so we need to look into this also. Okay, so this is the basic cost of the crude oil. But again, when the any company or any government is selling the product, there are other taxes also, there are other policies also. So based on those, the rate will again increase. Per liter rate is increased. Now this is a pie chart. So this is pie chart is explaining the world energy use. So you can say 33% energy is coming from oil, 30% from coal, okay, 24% from natural gas, 7% from hydro, 4% nuclear, and 2% other. So again you can see the major parts. So oil is 33%, again fossil, coal 30% fossil, natural gas 24%, again fossil. So humanity depends on fossil fuels for 87% of energy needs. So our 87% of energy needs are fulfilling from fossil fuels only. So it's very huge. The renewable part is only 7, 4 and 2%, very less. So that's why UN is working on it to increase the renewable energy. India is also working on this. Like regarding for natural gas, India is working on CBG. Anyone heard about CBG? Yeah, anyone have heard about CBG? What is the CBG? Anyone know about CNG?
Compressed natural gas.
Yeah, compressed natural gas. So can you give me some examples where we are using the CNG?
In auto,
Yeah, please turn on your video and you can explain about CNG. Actually, this was interactive class. If we interact, then it will be good for everyone. So everyone will get to know about some your ideas about some CNG or some other things also. So try to have interactive session. Okay. So who were explaining about CNG? Yeah, okay. You can if you don't want to turn on your video, okay, no issue. Just explain what is a CNG. What are the application of CNG? Anyone?
So CNG is used for fueling vehicles,
Okay.
and then it is used in houses for cooking,
Okay.
and also it is used for power generation. Is
Yeah.
it correct?
Yeah. Correct. Correct. So CNG is basically compressed natural gas. Okay. So it's basically natural gas. Why compressed is there? Because in automobiles, the density of CNG is less. Okay. So in suppose a automobile we want to run it for more and more kilometer. So if the density is less, we require more volume to store the more amount of gas. Okay. So what we do, we compress it. We compress it at 200 bar, 250 bar or 300 bar in some cylinders. Okay. So a small volume can contain more amount of gas. Okay. So basically, you can say CNG in auto, CNG cars are there today in Delhi. Like CNG buses are also there. So they all are using CNG kits. Okay. So in the CNG kit, yeah. Anyway. Okay, so basically we compress the natural gas and store in like some cylinders at 200 bar. So when the gas is stored at 200 bar, so in a small volume we can contain more gas. More gas mean more energy content is there. If more energy content is there, then your vehicle can run for more kilometers. Okay, that's why it's called compressed natural gas. We are also getting NG in the gas in the for cooking in our house also. That is called PNG, pipeline natural gas, not CNG. Okay, we call it PNG, pipeline natural gas. CNG for
Yes, sir.
automobiles. Yeah, compressed natural gas, because the gas we are getting in the house it's not compressed. Okay, that is that is having very nominal pressure only, so that it can flow. So it's pipe natural gas. Now come to CBG. Yeah,
PNG means
PNG is pipeline natural gas. Both are same. Natural gas are same. This is compressed only. CNG is compressed. Okay, it's pipeline natural gas. So maybe in the composition there will be some differences. Okay, there will be some difference, but these both are derived from the natural gas. Okay,
yes, sir.
both are derived from natural gas only, because based on the vehicle, the percentage of methane will be more in this CNG, and PNG. I think the percentage of methane like tolerance limit is little bit more as compared to that. But the main thing is that both are natural gas, so it is fossil fuel. Okay, we are not generating it, we are getting it from the nature. Okay, so in yeah, so the CNG part, this natural gas part for India is importing around 15% of gas. Okay, so currently we are importing 15% of natural gas. Okay, so so when we are importing something from other foreign countries, we need to spend the forex. Okay, the fund in that same particular currency only. So it's having a huge burden on our foreign currency reserve. Okay, so the India is planning to replace the CNG from CBG. So India is planning to replace the CNG from CBG. So India is planning to reduce the import of CNG by using the CBG. CBG is compressed biogas. We know biogas very well. So biogas basically the gas which is generated from the biodegradable waste. Okay, in anaerobic condition, like gobar gas. It's very old actually. Everyone know the gobar gas. Okay, but today we are generating the biogas not only from gobar, we are generating from agriculture residue. We are generating from the kitchen waste. Okay, we are generating from the animal manures, and we are generating from various type of waste. Okay, so biogas is very popular today, but biogas is having only 60% of methane CH4, and remaining 40% is around CO2, and the CS was around 50 to 60%. It can vary depending on the feedstock. So the composition of the biogas, it's the main component are CH4 and CO2, and there's some other gases like H2S is there. Some other gases are there, but the major component are CH4 and CO2. So CS4 is in the range of 50 to 60% depending on the feedstock. So, but we know that for vehicular application, we require CNG. So CNG is having CH4 content is around 90 to 95%. Okay, so around 95% is CH4. So we cannot use biogas directly in the transport application. Okay, so we need to upgrade it. So today in India, in IIT Delhi itself, the water scrubbing plant is there, and there are the other techniques also: water scrubbing, pressure swing adsorption technique, membrane separation. So there are various techniques by which we can remove the CO2 from the biogas. So if we remove the CO2, that was 40%, so what will remain? So only CS4 will be there. So CS4 can, the CS4 percentage can be increased up to 90 to 95 or 98%, depending on the upgrading technique. Okay, so basically we are upgrading the biogas and increasing the CS4 concentration in the biogas, and now we are compressing that biogas, so that is called CBG, compressed biogas. Okay, so there is biogas and you have upgraded the biogas. Now the this upgraded biogas, you have compressed it to 200 bar, so this CBG can replace the CNG. Okay, and you can directly use this CBG in CNG vehicle. Like you have, like suppose you are having a CNG car, you have already CNG kit installed in your car. Okay, so you now you can fill CBG directly, because the chemical composition will be, like the gases composition will be similar. So CNG composition will be similar to CBG. So CBG can replace the CNG. Okay. So Government of India is planning 5,000 biogas plants under Satat scheme. There is a scheme called Satat for transportation sector is there. So you can Google it about after this class. What is the Satat scheme? It's a very good scheme. Under this scheme, 5,000 biogas plants are planning. Government of India is planning to set up all over the India, and in those plants they were using the agriculture residue and different type of food industry waste, sugar industries waste and different type of waste material for generation of the biogas, and they will upgrade biogas to CBG, and they will replace the CNG in the market. So as of now, I think 3 to 4 CBG dispatching stations are also installed in different locations. One in Uttarakhand and one is in Delhi also. So CBG is a quite interesting topic. So today we are moving toward CBG. Government of India is making huge effort to replace the CNG using CBG. Okay. Now again come to the next question, what is the crude oil contains? Crude oil contains which elements crude oil contains, like carbon, hydrogen, oxygen and nitrogen. So we have covered that crude oil contains carbon, yeah, hydrogen also, oxygen, nitrogen, both. So it's contain all four components. Now next question is, the in the world energy uses pie chart, it is seen that most of energy currently used by humanity comes from. So we have seen in our this slide that 87% of our energy needs are coming from oil, coal and natural gas. So the correct answer will be fossil fuels. Now next question is, the condition under which crude oil forms uh, uh, crude oil forms are millions of years with. So there are some condition we have discussed. After those conditions met, then only,
Heat, absence of oxygen, millions of years.
yeah, heat, high pressure and absence of oxygen millions of years. So when only these conditions met, then only the dead animals, the dead plants, and everything organic matter can be converted to the fossil fuels. Heat, high pressure, absence of oxygen is the right answer. So, what is the conclusion from this first week lecture? So, anyone please explain what do you learn from the first week lecture, which taught by the Professor Pratap sir? Anyone want to explain their thoughts?
Sir, I will explain.
Yeah.
So, energy usage by humans can significantly impact the composition of the atmosphere. So, it mainly focused that energy used by humans is impact of composition of the atmosphere. So
Okay.
after that, this impact on the atmosphere can occur in a relatively short period of time. So this impact for atmosphere, this impact will be occur in a short period of time. That's all, sir.
So basically, please tell me what is the component which is impacting the atmosphere, which is impacting our lives actually, because we are using the energy is a very high rate. So what is the major component that is the main reason of this impact? Like you are right, we are getting some impact on our lives, our atmosphere, but what is the major component for that impact?
Sorry, sir, I can't understand.
Actually, I mean to say that you are saying that we are the impact on atmosphere can occur in a relative short period of time. So
Okay, sir.
we are talking about some impact. Okay.
Okay.
So some impact is happening on the atmosphere. So what is the reason for that impact? What is the main reason behind this impact?
Carbon emissions, sir.
Yeah, carbon emission and energy use, because we are using the energy is a very high rate from in last 100 years. Our energy demand increase in exponential manner, so our energy use has increased and we are exploiting the fossil fuels. So fossil fuels are emitting the carbon, so the CO2 concentration is increasing. So the CO2 concentration was 0.04% in the balanced atmosphere. That was the result of millions of years. Okay. So you need to understand that today we are living in an atmosphere. So this atmosphere is as a result of millions of year. Okay, because it take millions of year to to maintain this condition in which the human population can survive. Okay.
Yes, sir. Sir, and also I have one doubt.
Yeah.
So generating electricity is also impact, right, sir?
Yeah.
And also burning fossil fuels, heat by burning fossil fuels, also the impact, right, sir?
Yeah. Right. Right.
Okay, sir. Thank you.
Yeah. Because
So it is one of the impact on the atmosphere only, sir.
yeah. Yeah. Atmospheric impact. Yeah.
Okay, sir.
Yeah. Electricity, you are some people think that when we are burning only, so when you burn something you can see the smoke, so when you see the smoke then only you think that there is a pollution, but it's not the correct thing. You are getting the electricity, but that electricity is coming from where? Electricity is coming from grids, and in grids from where electricity is coming? So basically electricity is coming from some power plants. So how the power plants are generating that electricity? Again, they are using the coal. Okay, they are
Yes,
burning
sir.
the coal. They are burning the coal in the boiler. They are running the steam turbines. Okay, they are running some some other turbines using that steam. Okay, so based on that, they are only generating the electricity. So that electricity is transmitted through transmission line to our house. So we are thinking that electricity is not polluting the environment, but it's not correct. It depends how the electricity is generated. If you are using the solar, then you can say that your electricity is renewable. Your electricity is not polluting the environment. But if you are getting the electricity from some power plant, then you are just shifting the pollution. Okay, suppose today we are talking about electrical vehicles. Okay, but the main concern is that like we are saying electrical vehicles are good for the environment. Yeah, it's very good for environment, but again, how we are charging those electrical vehicles? If we are charging those electrical vehicles from the electricity obtained from the any thermal coal power plant, then again that energy just we are just transmitting the point of emission. Okay, like the emission is now not happening in the cities. Now the emission is happening at the location of power plant. Okay, suppose currently if we are using the vehicles that are using petrol diesel, and they are running in a city, then the pollution is generating in the city itself. Okay, but now we are using electrical vehicles, but again the electricity is not renewable, the electricity is not from solar, so we are just shifting the point of emission. Now we have shifted the point of emission to that particular power plant that is supplying the electricity. So it's a very important point, we need to look into it, that we need to completely know from where the electricity is coming. Okay, then only we can say it's carbon neutral, it's real green energy. It's very important point. So after this course you will learn about all these things. Okay, so
Yes, sir.
yeah, also the impact on atmosphere can occur in a relatively short period of time, because the population, the energy demand, okay, so it will change the atmosphere very quickly, because because the CO2 concentration, because you can say that today we are building infrastructures. So for the building the infrastructures we are cutting down the trees. So there is a huge deforestation happening all over the world. So today we are working on various technologies. So for carbon capture technologies, but we know the best carbon capture technology is the plants. Okay, it's trees, because the trees or plants can remove the carbon, remove the CO2. The best option, but again uh, we are we are doing deforestation. So in this way we cannot like sustain the best atmospheric level, best atmospheric composition that can be best for our health. Okay, so we need to focus on these parameters. Yeah, so anyone want to share their thoughts about energy scenario and fossil fuels? Anyone can share their thoughts. So if you are having any doubts regarding uh, this class, you can ask me, because this class is for 2 hours. So now I think the week one is covered, but we are left with 30 minutes. So in this 30 minutes, we can discuss some important topics. You can say, you can share your thoughts about energy. What do you think about? And you can also ask me something.
Sir, I have one doubt
Yeah,
regarding exam.
yeah, okay.
Sir, how was the questions and all having for exams? How to cover the syllabus?
Uh, like every week, there are some classes there. Okay.
Yes, sir.
So I think you have to cover those classes, those video lectures, and every week we are the like we are three TAs, so we will take like this type of live classes. In that we will discuss the important concepts and also solve some sample problems. So this will help you to understand the concept and how to solve the questions. And
Okay, sir.
there are assignment also after every week. So please submit the assignment before due date. So I
Okay,
think the 8th Feb is the due date for week one or week two assignments.
sir.
Yeah, so you have to submit the assignments on the due dates. So when the complete course will be covered, so you can also register for the exam.
Okay, sir. So now itself we have to register for exam, or else will take some times to register.
Yeah, I think there is a deadline specified on the portal. You can check the deadline. So there is a nominal
Okay,
charge. I think 1,000 rupee charge is there for the exam. So you can register for the exam. After that, you have to give the exam, and then only you will get this final certificate for this
okay,
course.
sir. Okay.
Yeah,
So for this exam, there is a pass mark, right? Pass mark.
yeah. Your assignment marks is also important. So try to submit all the assignments before due date.
Okay.
And in next class, I will discuss about the previous class of week one assignments that is due on 8th Feb. I will discuss that, and I will discuss the week two lecture material.
Yes.
anyone else is having any doubt? So regarding this pie chart, we can like discuss something more about it. So here we can see that the major demand is coming from the major supply is coming from oil, coal, and natural gas. So anyone can explain the what are the technologies we are using based on this? Based on this, anyone? Like oil, you can say 33% is coming from oil. So what are the sectors in this demand is coming? What are sectors from those they are using the oil? Anyone?
Natural oil. Hello.
Yeah. Hello.
Hello. Namaskar, sir.
Yeah, namaskar. Hello. Yeah, namaskar, sir.
Sir, you mean to say that natural gas is being used?
Yeah. Actually, I'm saying that we are having like oil 33% demand is like humanity depends on fossil fuels for 87% of our energy needs.
Okay,
So
yes.
from our energy needs, we are getting 33% from oil,
Okay,
30% from coal, and
yeah,
24% from this case. Okay. So in
okay.
33%, what
Hmm.
factors are coming? Like what technologies in using we are oil? We are using the oil. What application we are using the oil? What do you think?
Applications of the oil in the various sectors where we have directly we use it in automobile engineering, automobiles,
Yeah.
and we are also using, of course, non-energy level. We can say lubricants. There also we are getting from that oil.
Yeah, we are getting in lubricants also. You're right.
Also, and these majorly we are using for the oils to segregation, the fractional distillation to get the different types of fuels like kerosene and petrol, thereafter diesel, different and bitumen, etc.
Yeah, right.
The petroleum product we can say, sir.
Yeah,
Is it?
right, correct.
Okay, sir. And these are being directly used in automobiles, and even sometimes natural gases are sorry, the coal gas is also used in industry also for heating purposes.
Yeah, oil is
Uh,
also using in decentralized application. You can
okay,
say, yeah, our farmers are using diesel very much
yeah,
actually for their
diesel.
yeah. So that is also a major component
Mm.
because in decentralized location where they are using the generators. Okay, so they are using the diesel. So
Mm-hmm.
that is also a one point. And we are
Yes, bro.
yeah. So basically the oil is used for power generation, for automobiles, for lubricants, for industry purpose. So there are various needs, in where various demands where we are using the oil. The coal is basically what is the demand for coal? What are the application for coal? Major application?
Major applications are as a fuel, sir. It is as a used as a fuel for thermal power plants,
Yeah, right. So
and
basic yeah
yeah, it is basically fuel only.
yeah
And thereafter there are some components where the charcoals are being manufactured, and processed charcoals are used for making some what is lubrication, carbon lubricating oil. They are additives that they are adding, and so majorly coal is employed for the heating purposes, and thereafter the heat energy will be converted into the mechanical and
mechanical electrical energy.
electric energy.
Yeah. So coal is basically for power generation because like NTPC is the major user of coal because the maximum of our power plants are fed with the coal only. So we are getting the electricity in our house. In the house electricity is coming from the grids, and grids are getting electricity from the power plants. So the coal is basically used for power plants and some other like application as we discussed like for charcoal also for some heating purpose also. Now come to the natural gas. So this is having wide application. So what are the application of natural gas?
Natural gas is also used as a compressed natural gas for automobiles,
Yeah, right. CNG for automobiles. Yeah.
and it is also used in some other countries where the predominantly we have low temperature countries where it is used as a heating for heating purpose also.
Yeah, right, right. Like
And
in Europe,
uh,
the natural gas is used for heating the houses. They are having huge demand of natural gas, and due to this Russia and Ukraine war, they were facing very shortage of this natural gas, so they are shifting toward biogas. Now, what is your thoughts about biogas?
biogas is again it is a the decomposition of the biomaterials or burning of wood and all these things we are getting.
Yeah.
And it is used for household purpose, domestic purposes
Okay.
mainly. And we have Bharat bio plants and others also. Even government is encouraging that, sir.
Okay.
Then, however, this majorly is obtained by the burning of bio components only.
No, no. Biogas is not operated
No,
for burning
sorry,
actually.
not burning. I mean to say, it is obtained by the from biomaterials only.
Yeah. So biogas is basically produced from the anaerobic digestion, the digestion in
Yes, sir.
absence of the oxygen.
Yes, sir. Yes, yes, sir.
Okay, so anaerobic digestion generate the biogas from biodegradable materials,
Yeah,
from
but
organic material. So any organic material can generate the biogas. So my question is that is biogas like you can say we are saying that biogas is renewable, but again biogas is having CH4 plus CO2.
yes, sir.
So how can we say it's renewable? What is the reason? It's also having CO2, and we know that CO2 is the greenhouse gas.
Greenhouse gas, even
So
methane also.
yeah, methane is also greenhouse gas. Yeah, but
Hmm.
it can generate the power. So like biogas is also when we are burning the CH4 again we are getting CO2. So why
Carbon
the
dioxide.
biogas is called renewable? What is the reason for that?
The renewable because it is a it is obtained by the biodegradable materials, and it can be replenished the rate at which it is being consumed. Suppose if we cutting the tree, that thereafter getting we can grow it in a certain rate of times within which we are going to consume it. That's why it is little bit commented as a, I mean, categorized as a renewable.
Yeah. Normally we say it's a carbon neutral. Actually, we are emitting the carbon, but it's carbon neutral because
Carbon.
yeah,
uh,
because the like biogas we are generating the biogas from some organic matter. So that
ah,
organic matter has already consumed the carbon.
mhm.
Okay, so basically that matter consumed the carbon and again it's generating some carbon. So basically biogas is carbon neutral.
Okay.
So now
Okay.
biogas is in very focus. Actually, like you were saying that biogas is basically used for heating purpose only in the rural areas. But now it's not a scenario. Actually, I am also a PhD scholar and I am working on a topic biogas to power and hydrogen. So now in India and in all over the world, the researchers are developing technologies in which they can use the biogas to generate the power, to generate the hydrogen, and to do various things actually, like CBG. Like India is also promoting the CBG, compressed biogas. Okay, I think you have joined late in this
Wait,
class.
yes,
Yeah,
sir. Yes, sir. I'm
yeah.
sorry, sir.
No issue, no issue. Okay, so I will again explain about CBG. So CBG is basically compressed biogas. Okay, so because biogas is having 55 to 60% of methane content in it. Biogas is having 55 to 65% methane content and around 40% CO2 content. But the CNG is having around more than 90% of methane. So for a vehicle application, we require more than 90% of methane. So we cannot use biogas directly in any vehicle or in any CNG kit. But when we remove the CO2 content from the biogas, so the CH4 will be increased. So there are various techniques. Using those we can upgrade the biogas, okay, and upgrade the methane content in the biogas. So normally in India we are using pressure swing adsorption, we are using water scrubbing, we are using some membrane separation. So using these techniques, we can remove the CO2 and we can increase the CH4 concentration in the biogas. So that biogas will become equivalent to CNG. Because if you are having 90% of methane content in a gas, then that can be used for power generation. Okay. So the composition of biogas can be similar to CNG. Okay, so that is called CBG. So in government of India is planning to establish 5,000 biogas plants, big biogas plants all over the India, and around I think 3,700 letter of intent has already issued, and around 41 biogas plant has already set up at different locations. So basically, these plants are using agriculture residues. These plants are using the biodegradable waste from the food industries. Okay, like you can say in Punjab also. So the India's biggest biogas plant is in Punjab. I think in news you all heard about the Parali. So
Uh-huh.
yeah, you heard about the
Well,
Parali. So the farmers burned the Parali, and that pollution directly impacting the Delhi actually. So now those farmer can sell the parali to those biogas plants, and those biogas plants are using those parali to generate the biogas, and this biogas is upgrading to CBG, and that CBG is dispensing so sorry that CBG is dispatching to the various location as a CNG. So government of India is planning to replace the CNG using the CBG. So currently government of India is planning to reduce the import of natural gas because we are expanding our forex reserve, we are expanding our foreign currency to buy the natural gas. Like currently we are importing 15% natural gas from other countries. So we are planning to reduce it to 6%. So we are planning to increase the share of CBG in this energy sector. So this is a great topic, and my research is also based on the biogas. I am also working on biogas to power and hydrogen. So today biogas can be used for various applications, and in like 5 to 7 years, you will see that this pie chart will also have some component for biogas. Yeah. So any other your opinion about this? Any opinion? Anyone?
excuse me, sir.
Yeah.
Sir, actually, I just wanted to know. You just now said that, yeah, the biogas, power, and hydrogen.
Yeah.
So, can you little bit throw some light on that? This biogas, how can be converted into
Yeah, yeah,
hydrogen?
yeah.
Power.
Actually, today all over the world, we are
Mm,
generating the hydrogen. 96% of the world hydrogen is
mm,
generated from the fossil fuel only. Like we are
mm,
generating the hydrogen from coal and
mm,
then and methane, natural gas. So we are using some reforming techniques like steam methane reforming is very famous technique is commercially available in the market, and all over the world it's very popular. And for the coal we are using the gasification. So there are various techniques. Using those we can generate the hydrogen from natural gas and coal. So steam methane reforming is basically use the methane and use the steam, and the steam and methane can react at higher temperature around 700 degree in the presence of some catalyst, and generate the syngas, carbon monoxide and hydrogen, and further you can purify that syngas to pure hydrogen. So based on
mm.
that, now you have
That
upgraded
is
the now.
water gas. That is water gas, I think.
No, syngas, CO plus H2. Water gas
Uh,
shift reactor, yeah, water gas shift reactor is that. So we have used water gas shift reactor to further convert the CO into H2.
Okay.
Yeah. So basically, first we convert the CH4 react with the steam H2O. They generate the CO and H2. After that, in water gas shift reactor, again we are having some catalyst. So there's that catalyst again convert the remaining CO into the hydrogen and CO2. So in this way, we are getting the hydrogen. So today, world's 96% of hydrogen is generated from the fossil fuel. Around 48 or 52% is from the natural gas using steam methane reforming, and remaining is from coal using gasification techniques. So the biogas, so biogas can replace this because we can upgrade the biogas to CBG. So CBG is equivalent to your CNG, and so because the CS4 content is around more than 90%. So instead of the biogas, instead of the methane, you can use the biogas. You can use the CBG for your steam methane reforming reactions. And there are various techniques. There are other various techniques also in which you can use directly biogas to generate the hydrogen. Like dry reforming is also there because biogas is having CH4 and CO2. So CH4 and CO2 also can also react at higher temperature. So this is called dry reforming. It's also under research. So in dry reforming, we can also generate the hydrogen. So there are today all over the world various researchers are focusing on biogas. So I think my answer enlightened you about the biogas to hydrogen.
Yes, sir. Substantially. Thank
Yeah,
you, sir.
yeah. You can you can see more articles on this topic. You can see online. Yeah,
Uh-huh.
there are number of articles available.
Uh-huh.
Yeah.
Mhm.
So anyone else about like energy scenario? Anyone else want to give their thoughts? What do you like? What are you thinking about this? So again, I am explaining about like I think some people joined at the end. So every week we will have a live session. So basically, we are having like for this course, non-conventional energy resources. We are three TAs. So my name is Amit Kumar Sharma. So I will take classes on Monday, 6 to 8 p.m. Every Monday, I will take 2 hour class, and in every class, I will discuss the previous week important concepts, and I will discuss some important questions also, and discuss how to solve those questions. Okay, so in this is the first live session. In this session, I have covered the week one concepts and week one some important questions about the week one lectures. So next week also I will take the class. Okay, so please try to attend the classes. It will be very helpful for you. And these are the interactive session. So in this session we can discuss about the class topics, and we can also discuss about the energy resources because this yeah.
Uh, Sir, will you share this PPT in email or?
Yeah, please, yeah. So this session is being recorded, and the PPT is also shared with you. So I will make a Google Drive link, and the team, the NPTEL team, will share the link and the video also. I
Yes, sir.
will, yeah, I will upload the recording video on my YouTube channel. So that link will be shared with you, so you can watch this recording on YouTube also.
May I know what is your email? Sorry, YouTube channel
Yeah.
name?
Yeah. The link will be shared. The link will be shared with you.
Yes, sir. Thank you.
Yeah. After this class, the link will be shared with you. The PPT will be shared with you. The all content will be shared with you.
Okay, sir.
Yeah. So you can, yeah. Tomorrow also we are having session. Like other two TAs will take the session from 6 to 8 and 7 to 9, I think. So yeah, like your friends who were not able to join today, they can join tomorrow also, and you can also join tomorrow also. No issue. They will also cover the week one classes. and you can take the classes and know what will they cover. So basically, this is the theme of this live sessions. We will discuss about things. We will cover the topics from the last week, and we will discuss some of the important areas.
Uh, Sir, there are the three different timings have been mentioned in the mail what we have received.
Yeah, yeah, right, right.
So, is it necessary for us all the session we live sessions we are supposed to attend?
No, 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 no. There is no mandatory clause to attend the live session. It's
Uh,
it's for you. Like if you want to know about more, want to know how to solve the assignment question, and you like to revise the brief concept of the lectures, then you can attend. You
so
can,
this
yeah,
Of course, it is a very wonderful thing, sir. We are supposed to, and I would like to join all the time, but because of our other schedules, so we can opt for one particular session wherein we can stick to that particular timing. Is it the motto behind that, giving the different timings?
yeah, yeah, yeah. Actually, the number of participant in this course is very high.
Yeah, yes, sir.
Yeah, yeah. So that's why we are having three sessions,
Okay.
because it's not possible to every person to join a particular time.
Yes, sir. Yes.
So
Yes.
in every week we are having three time slots. So in
Uh-huh.
three time slots there are number of high probability that anyone can join. So
Uh-huh.
yeah, this is the motto behind this. Yeah,
Every particular different timings in a week, they are going to take up a particular topics which are being taught in previous
yeah. Previous week. Yeah,
weeks only.
yeah, yeah,
So, okay, that's very nice, sir. I got it because since I'm very sorry that I joined today little bit late
no,
or
no, no, no.
not
It's
late,
yeah, it's
late.
okay. Yeah, yeah. No issue.
So it's a wonderful session, sir. Thank you very
Yeah,
much,
thank you, thank you.
and we hopes that we will be going to join you again and again on Monday. It would be convenient for particularly me between 6 to 8.
Yeah, 6 to 8. Yeah, right, right. And next time I will try to change the this meeting link. Actually, in this Google Meet, I am facing some issue that I'm not able to bypass the lobby. So every time I need to go to this main page and need to admit the participants. So next time I will try to change the Teams link. So I will update you on the announcement page. So the new link will be shared with you maybe for the next session.
Yes, sir. On
Yeah,
the same date, same date will be same.
date will be, the timing will be same, Monday
Sorry,
6 to 8.
Monday. Monday and timing will be same. Sorry.
Yeah, yeah,
Mhm.
Monday timing will be same,
Uh-huh.
but the link may be changed.
Okay.
So please be aware.
Mhm.
Yeah.
Okay.
So anything else anyone want to anyone want to share about this class, and if you want to include anything else we can discuss. So for next class we can discuss those things also.
Hello.
Hello. Yeah, anyone want to share their thoughts about this course?
Yes, sir. About this course, entire course.
Yeah. So
Uh,
what are you expecting to learn from this course? Actually, non-conventional energy resources.
Basically, I am a teacher and I have to teach this non-conventional course to our diploma level students.
Okay.
And it's a wonderful session. I had I could not give the examination in the previous run.
Okay. Okay.
I enrolled myself, but I could not give the examination. This time, I would like to take up the examination, and I was fascinated by the way in which these sessions are being conducted, the teachings are, and it's a very useful for me. And we are just doing some small projects for my students as well. So that is the purpose why we joined this one, sir.
Okay. Okay.
And
It's very
this
nice thing. Yeah.
and moreover, last time there was no live session. A couple of live sessions were there. I missed it. However, this time it is a very planned and meticulously planned live sessions are there. So therefore, we are very much on behalf of myself. I am thankful for arranging such an interactions with a pioneer teamwork. team members who are directly talking to us, and that will be a great help for us to endure the further things.
Yeah. Thank you very much. Yeah. Uh, I want to say that please cover every week classes also. Because every week I think there will be three classes from the professor. So
Hmm.
please cover those classes, and
Ah,
after those classes, this live session will be very helpful for you, because in
yeah,
this live
yes,
session
sir.
you will directly learn all the. It will be like a revision only.
Yes, sir. Yes, sir.
Yeah. So
Mm.
please try to cover the classes from
And
professor. Yeah.
one is second slide is there, no, sir. Second slide.
Yeah.
That is a measurement. Sorry, the yes.
Yeah.
In this case, professor gave some examples also, and there are some capacity, because I am not from the electrical branch and electrical engineering,
Yeah.
and therefore uh, there is a capacity, the capacity of a particular appliance, and there some of the appliance have been mentioned. The what about the particular, because the we have to calculate the energy consumption of a house using these capacity, and the this power that it takes up
Yeah.
for.
Right.
So,
Right.
so that power, and we are not having any particularly, sir said about the Hubble's telescope, what it consumes the power, and the they orbit it 95 what is it, 95 minutes it requires to take the five orbits and all this thing. That is a great help for us, which will take up to calculations and also, and the calculations of carbon dioxide parameters, where when we can able to what time frame within which we are going to able, at the same rate pace at which we are going to use the 500 exajoules, and thereafter
Yeah.
what
Right.
is the
Right.
time. That's a wonderful exercise for us, and that type of what really expected from the platform like this, and that is really achieved. And we need some capacity. Some of the capacities are not mentioned there. So if it will be disseminated for us, for our own consumption, that would be a great help.
Yeah. Right. Yeah. Okay. Thank you for your thoughts. And I
Thank
think,
you, sir.
I think it's wonderful you are attending the classes and you are attending this live session. It's very wonderful for all of you that you have attended this 2 hours live session. And
Yes, sir.
yeah. Thank you everyone for attending this lesson. So next week I will also take the lesson. Okay. So try
Okay.
to,
Yes,
yeah. Please attend that also. And
No need to say please, sir. It is our
yeah.
it is it's our pleasure to attend the session.
Yeah. Okay. Nice. So I think the time is completed. So I'm stop
Okay.
presenting.
Okay. Thank you, sir.
Yeah. So thank you everyone. So we will meet next Monday.
yes,
Okay.
sir. Sure.
Yeah. We will cover the week 2 classes in the next Monday.
Yes, sir. Sure.
Okay. Thank you very much.
Thank you.
Yeah. Okay. You can leave the meeting. Yeah. Bye.
Yes, sir.
Hello.
Hello.
Yes, sir. Sir, the timing of your class and the fundamental of automotive class is same, sir.
Okay. So there is no issue. You can join. Like we are having 2 sessions. Total 3 sessions actually. So
Okay.
for week one, we are three TAs. So I am taking class on Monday. So there are also like tomorrow is also classes there. You have received the email now. In email, like three slots are mentioned. So you
Okay,
you
sir.
you can join any one slot. Okay, no issue.
Okay, sir.
So
Okay.
in every slot we will cover the week one content only.
Okay, sir.
Okay. Thank you very
Thank you.
much. Okay.
Thank you.
Okay.